So this is actually January 2020, and it's on page 87 of the paper 2. Is it all found?
Yes, miss.
Yes, miss.
So the question reads, the radius of each circle is 7 cm. The circle fits exactly into a rectangle. Let me see if I could get something to show you just now. All right, so this is my box and it's rectangular, just like what we have there. And in it, I have circles. So all these circles actually fill from one side to the other side. Notice, because we are putting a circle inside of a rectangle, in between there will be spaces. So there will be spaces in between each of the circles in the rectangle. So it is made up of a rectangle with circles in it. And because the two shapes are different, in between there will be spaces. Now, the circles fit exactly, meaning that the circles fit from one end to the other. They ask you to show that the area is 2,352. Now, two formulas that are of utmost importance that you are supposed to know is area of a rectangle. We have been learning this since primary school. Length by width. Area of a circle, which is pi r squared. Whenever you are working with circles, you need to ensure that the radius is given and not the diameter. So the radius is 7. So find for me the area of the rectangle. Find for me the area of one circle multiplied by 12, and you should be able, no, they ask for just the area of the rectangle. Oh, sorry. Now, let us see if we could figure out the length of the rectangle. So here would be 7 plus 7. Here would also be 7 plus 7. Here would be 7 plus 7. 7 plus 7. What is the length and what is the width of the rectangle? Can anyone tell me?
The length is 56 and the width is 42.
All right. 56 centimeters and the width is 42 centimeters. Does anybody agree with her?
Yes, miss.
So this line is 56 centimeters. Now, if we go in this direction to get the width, each circle has a diameter of 14, and we have 3 circles, 1, 2, 3. So the length here will be 14 by 3, which is 42. Now, use the formula and prove that 56 multiplied by 42 will indeed give us this answer. So take a minute and work it out. Because we are multiplying two lengths, area is two-dimensional and it is centimeter squared. Did you all get this?
Yeah, miss.
Yes.
Correct. Now, remember the box that I had just now. So I told you that these circles fit exactly from one end to the other, right? But we have spaces in between. So the next part is to calculate the area of the shaded region. So we need to work out the area of one circle and multiply it by 12, because in this diagram, we have 12 circles. So find the area of one circle for me. The radius is 7. Area of a circle is pi r squared. So the area of 12 circles will be 12 by the answer that you got before. And the area of the shaded region is equal to 2352 minus the answer for the previous part. So work it out.
The area of one circle is 154 cm square.
All right. Just give them a minute. Let's see how quickly they can do it, and you'll give me the answer in a few minutes, right? All right, let me know when you all are finished. All right, Rihanna, go ahead. What is the area that you were giving me?
1,848 cm
Oh, the
square.
area of one circle.
Oh, 154 cm square.
Could anybody confirm that this is the answer?
Yes, miss.
All right. Let us multiply that by 12 now. We will get 1,848. And when we subtract it from 2352, we will get 504 centimeters squared. Remember to put your units. Area is two-dimensional. Did you all get that?
Yeah, miss.
All right, so let me leave it in case anybody wishes to take it down. Then we will go to the next part. Is anyone still writing?
No, miss.
The diagram below, not drawn to scale, shows a triangle MNP in which the angle at P is the angle at M. So what type of triangle has two angles that are the same? How do we call that triangle?
Isosceles triangle, miss.
An isosceles triangle. So if we have two angles the same, what information do you know about the sides?
They're equal.
Right? We have two sides and two angles that are equal, not so? Right. So here also will be 12.5 centimeters. So this is called an isosceles triangle. How many degrees in a triangle? 180 or 360?
180.
180.
So we know two sides, we know two angles. Work out the third one. Take a minute or two and work out the third angle.
That's 76 degrees.
So here is 76 degrees. Did anybody else get that?
Yes, miss.
Yes, miss.
All right, so we have one mark here, we have one mark here. So that wasn't too bad at all. They asked to calculate the area of the triangle, but from what we know, a triangle is supposed to have base and height. But is there another formula that we can use? So let's go to the front cover of the booklet. Now, this is a triangle. We have a half base by height, where B is the length and H is the perpendicular height. But in the triangle just now, which is the isosceles, we don't have that. However, there is another formula. An area of a triangle, which is an isosceles or a scalene or a triangle that doesn't have a height, we use a half AB sine C. So AB are the sides of the triangle and C is the angle. So in case you forget, it is in the front cover of your booklet. Also, the cosine and the sine rule is found there, the trigonometric ratios. You even have area of a circle, area of a sector, area of a trapezium. You even have volume of a cylinder, volume of a prism, circumference. So there's a formula sheet to the front of the booklet. If you cannot remember, please don't make up your own formulas. Go to the front cover of the booklet and you will see it right after the instruction page. So this is the triangle here that we have. I draw it upside down. Listen. So here is 56. Here is 56. This is 12.52. Thank you. 52, 52. Here is 12.5. Here is 12.5. So this is my A and this is my B here. And C is the angle. So the angle here is 76. So we're going to use the formula area of a triangle is a half AB sine C. So take it down. Even if you have it and you have the answer, check it over before we actually give the answer. So check it over, even if you have it in your booklet. The rest of you all try it for me, please. All right, who has an answer? Point 5 by 12.5 by 12.5, sine 76. The answer is 75.8 centimeters squared. Did you all get that?
Yeah, miss.
All right, is there anybody who tried the question and didn't get it? All right, turn to page 153 in your booklet. Page 153. This is July 2021, page 153. Is it found?
Yes,
Yes,
miss.
miss.
Right. So just like what we were doing yesterday, this is Farmer Brown's box. Farmer Brown makes troughs to feed his animals with wood that is 5. With wood that is 5 centimeters thick. So the thickness of the wood that Farmer Brown gets to use to make his trough is 5 centimeters thick. The troughs are rectangular base and it is open at the top. So there are 1, 2, 3, 4, 5 faces. The open to the top, so the bottom here, there's only one face here. These two have the same dimension. These two faces have the same dimensions. Show by calculation the internal capacity of volume in the trough is 8,091,000 centimeter cube. Now, they ask you for the internal capacity. So it means that the external capacity is measuring 300 by 190 by 160. However, because of the thickness of the wood, the dimensions of the internal capacity is slightly smaller. Do you all agree?
Yes, miss.
So if this is my face inside here, and this length of this side here is 300, and this length here is 300, right? So we have 300 by, well, we have 300, this is the length. We now have to find the internal capacity. So we need to find the length, we need to find the width, and we need to find the height. Taking into consideration that it is 5 centimeters thick throughout. So here would be 5 cm, and here will also be 5 cm. So it means that the 300 centimeter length will be less 5 cm on one side and less 5 cm on the other side, because it's 5 cm thick on either side. Let's look at this side now, which is 190. Now, this is the short side. So if this is the short side, we know the external length or the external width is 190. But inside here now, it is slightly smaller because there is a thickness. And there's a thickness on this side. And because this side is the same thing, there's a thickness on this side as well. So Farmer Brown's box, the width is 190, but we have to take into consideration the 5 cm on this side and the 5 cm on this side. Let's go to the top now. We don't have any covering. So it is only 5 centimeters thick at the bottom. You remember yesterday when I filled the contents of the glass? I don't have the glass, but the glass was thick at the bottom. We were not able to fill the entire capacity. So if the height is 160 and there is no covering, I just have to account for the 5 cm thickness at the bottom. Not on both sides because the trough is open. So let us use what we have and work out the internal capacity. I told you all yesterday, if it's a cuboid in shape, and we want to find volume, volume is 3-dimensional. So we need to multiply the length by the width by the height. Volume is 3-dimensional, and we multiply 3 sides. So let's do that. Volume, length by width by height. So the length, which is 300, I am going to subtract 5 cm on this side and 5 cm on this side. So I'm going to subtract 10. In the length now, or the width, I am subtracting 5 and 5. So this will be 190 minus 10. And for the height, I am only subtracting 15 centimeters. So this is 160 minus 5. So 300 minus 10 is 290. 190 minus 10 is 180. And 160 minus 5 is 155. Multiply it and you should get this value. So multiply 290 by 180 by 155, and you should get 8,091,000. Are we finished?
Finishing.
Are we finished?
Yeah, miss.
So I included the internal dimensions there so that you will be able to visualize it, right? Calculate the volume of wood needed to make the trough. So take down the formula. The volume of wood needed is the external volume which is the 300 by the 190 by the 160 minus the internal volume. We already worked out the internal volume in the previous part. So it's up to you now to work out the external volume. Go ahead, work out the external volume. I should have done it here. I'm gonna do it here. So you could see the volume needed is the external, so you're using the larger values now, minus the internal volume. So we have the inside, we know the inside is smaller than the outside. We use any larger values on the outside. Go ahead, try it.
Miss 2,120,000.
All right, let's see if you are correct, Tiffany. 300 by 190 by 160. I got 9,120,000. So check back your answer and see. All right, anybody has an answer?
Yeah, miss. I got 1,290,000.
Miss, I get that same one where you get.
All right, very good. Is there anybody who didn't get that? Let's go. All right. Farmer Brown must paint the internal surface of the trough. Given 1 gallon of paint covers approximately 280,000 of surface. Determine the total amount of paint in liters that is needed to paint the internal surface of the trough. Now, when you all paint your room, or if mommy or daddy or auntie or uncle buys paint to paint your room, we are painting the inside. So Farmer Brown isn't painting the outside, but he is painting the internal surface. And what we are looking at is area. So in my box, which is Farmer Brown's trough, he has one to the back. This is one face. Remember, it have no covering. Then he has the short side here, here and here. Then he has the 2 long sides to paint. So Farmer Brown has 5 faces to paint. We have the large face to the back, and we have 2 small faces and 2 long faces. So Farmer Brown wants to paint the inside of this trough. There are 5 faces. So let us do it bit by bit. The first face that we have right here is measuring 155 by 290. And this is the same face in the back here. Do you all agree?
Yes, Miss.
So this face is the same face here. So we're going to multiply this area by 2. So then we have to multiply the long side now. So we have the long rectangular side. So this is measuring 180, and the height here is 155. So this face here is the same face as this one. So this area we're going to multiply by 2. And to the bottom of the box, we have a big face. And this is measuring 290. No, it's measuring 290 by 180. So this is the big face in the bottom of the box, 290 by 180. So work out the area of this rectangle multiplied by 2. Work out the area of this rectangle multiplied by 2. Work out the area of this rectangle. Remember, the large face to the bottom of the box, we're not covering it. So Farmer Brown just needs to paint the base. So he has to paint the base of the trough, which is the large face. This is the face measuring 290 by 180. As he is finished painting that face, he has 2 long rectangular faces to paint. So the long side, the length is 290 and the width is 155. So after he paints the 2 long sides, guess what? He has 2 faces again to paint. So Farmer Brown is going to paint 2 short rectangular faces. And this length here is 180. That is the shorter side by 155. So take a few minutes and work it out. If you have finished before, check over your answer, please. So what we are finding is called total surface area. The area of all the surfaces in Farmer Brown's trough. All right, let me see what you have. So this area, $290 by $155. 44,950. Multiplying that by 2, we'll get 89,900 cm squared. The second one, the area here, 180 by 155, 27,900. We multiply that by 2, we will get 55,800. And the last one, 290 by 180, is 52,200. The total surface area that Farmer Brown has to cover is 197,900 cm squared. Did anybody get it? Did you all get that? Or were you all still working it out?
Yeah, miss.
All right, did anybody else get it as well besides Rihanna?
Yeah, miss.
All right, so in case anybody didn't get it, let me leave it up in the screen for you all to take it out. Right, is anyone still writing? All right. Now, 1 gallon paints this amount, but this is 280,000. But his surface area is 197. So he would not need a whole gallon of paint. He will need a fraction of a gallon because 1 gallon covers 280,000. But he doesn't have 280,000 of centimeters squared. He has 197. So the internal surface that he has to cover is a fraction. So we put the larger number, which is 280,000 underneath, and we put 197,900 on top. And we want to know how many liters. We multiply this by 3.79 because 1 gallon covers 379. So he would need 3.79 gallons. He will need less than that because he doesn't have the amount of surface to cover. So 197,900 divided by 280,000 multiplied by 3.79. How many liters of paint will Farmer Brown need? Work it out and see what you get. Yeah? All right. Does anybody have an answer? Does anybody have an answer? How many liters will he need?
2.678.
Yes, 2.678 liters. Now, let me try and explain this, right? 1 gallon is 3 liters and something. Farmer Brown doesn't need 1 gallon. Why? Because the surface he has to cover, this value is smaller than this. This is the amount of surface that 1 gallon covers. So that is why it is a fraction. And we want to know the amount of liters, so we multiply it by 3.79. So Farmer Brown, if he buys 1 gallon, he's wasting his money. It is best if he buys the paint in liters because he will actually save because he doesn't even need 3 liters. But if he buys 1 gallon, he will have extra paint. Do you all understand that?
Yeah, miss.
All right, so it's 6:20. We're taking a break for 10 minutes. When we come back, we have 1 question again to complete. Is it found?
Yes, miss.
All right. So remember that we need to read the beginning of the question. That will give us a lot of information. Question 6 is measurement. It deals with volumes and area, right? And this is Jan 2022, page 182. At a track meet, a cylindrical container. So I want you to underline the word cylindrical. So therefore, if it is a cylinder, let me go to my front cover because I can't remember the formula for don't have it in this booklet. In this one. If you cannot remember the volume of a cylinder, this is the volume. So you have no reason why you should get this question wrong. So we're going back. Pi r squared height. So let's write it one time. So we will have it. Volume is pi r squared height. And this is the volume of a cylinder. So we're building upon as we go. Fitted with a pipe as drawn in the diagram is used to serve water to athletes. The cylindrical container has a radius of 12 centimeters and the height is 20. So we want to circle this in the booklet and we want to write it by our formula. If the diameter is given, we had to divide by 2 to find the radius. However, r is 12 and the height is 20 cm. So just by reading the top of the question, look how much information I am able to get. So we have a cylinder and we are going to fill water for the athletes. The water is being filled in cone-shaped cups. The cone-shaped cups have a radius of 8. So we're going to write it here. The cone-shaped cups have a radius of 3, and a height of 8. So we're going to underline that. R is 3, height is 8. So that information is important as well. Now, they ask for the volume of water in liters. So we want to underline that. We will be able to give our answer in centimeter cube. The question is worth 3 marks. So which means you are supposed to know that after working out the answer in centimeter cube to convert it to liters, you are supposed to know to do that. So we have all the information that's necessary to find the volume of the cylinder. We have the radius, we have the height. Using this formula and substituting these values, find for me the volume of water in the cylindrical container. Go ahead. You have the formula, use it. Since they want the answer in 2 decimal places, we can use pi as the decimal, 3.142. So go ahead, substitute it into the formula and see what you get. And remember, the answer will be in centimeter cube because we are multiplying centimeter by centimeter by centimeter. Then we will convert it to liters. So pi 3.142. If you decide to use pi as 22/7, that's fine. I am just using the decimal version because they ask for the answer correct to 2 decimal places. Multiply by 12, multiply by 12, multiply by 20. The answer, 9,048.96 centimeter cube. Did anybody get that?
Yeah, miss.
Yes, miss.
No, this is in centimeter cube. To convert from centimeter cube to liters, we simply divide by 1,000. So divide this by 1,000 and write your answer for me to 2 decimal places. Go ahead. Here you will get 9.04896. This is my 2 decimal places. This number is greater than 5. So the answer is 9.05 liters. If you put anything other than that, for this part, you will get it wrong. You will get 2 marks here for this answer. And because it is an accuracy question, you must put 9.05 to get the additional mark. Did you all get that?
Yes, miss. Yeah, miss.
Now we have all had a snow cone at some point in time. We know that a snow cone, that snow cone cup that they used to have a little while ago, is actually cone shaped. So what I realized, besides the cuboid and besides the cylinder, CXC has gotten in the habit of bringing the cone. So we need to learn it, and we need to learn it properly. They like to bring the cone. This is a couple times I've seen them bring it, and we're not sure what they're going to bring for you all. So let us take our time and see how best we could answer this. So water is flowing from the container down the pipe, from the container down the pipe into the cone-shaped cup. From the container down the pipe into the cone-shaped cup. However, the rate is 7.8 milliliters per second. We want to know how long it will take to fill one of the empty cone-shaped cups. So we need to know the volume of the cone-shaped cups. And because it's not in the formula sheet, they decided to include it for you. So in order for me to know how much time it takes to fill this cone-shaped cups, I need to know the capacity. I need to know how much water goes into that. So I will need to know the formula of the cone-shaped cup. I will need to know the radius, and I will need to know the height. Going back in my question, the radius is 3, the height is 8. They have given you every single information for you to answer the question. So let's go. Radius 3, height 5. V is equal to 1/3 pi r squared height. Substitute the values and find the volume.
Yes, the height is 8.
The height is 8. All right. Thank you. 8 centimeters. height is 8 and the radius is 3. Go ahead. You could use pi as 3.142. All right, does anybody have an answer? Does anybody have an answer? Or are you also looking?
75.36.
75 point, how much?
36.
36, all right. The 75 is correct, but I didn't get the 36. Did you use 22/7, Jordan?
No, miss. 3.14.
But check it back, unless it's 1/3 and not a half. Check it back and see. By 3, by 3, by 8. I have 75.408. Check it back.
Yeah, miss.
All right. Now, even if you don't know the formula for rate, watch this. This here is this is the volume. So therefore, if we want to find the time, we could simply cross multiply here. So the time taken will be 75.408 divided by the rate. So divide that by 7.8 and see how long, and they want the answer to the nearest second. So if you work it out, you'll get 2 marks. If you write it to the nearest second, you'll get the full 3 marks. Anybody with an answer? $75.408 divided by 7.8.
It's 9.667.
9.667, right? When we round it to the nearest second, this becomes 10 seconds. So remember, if you had this answer, you get 2 marks. They did ask for the nearest second, so you have to put it to 10. Did anybody else besides Nicole get that?
Yes, miss.
Right.
Yes, miss.
This last part is a giveaway. So they're going to use the capacity. They're using the volume of the cylinder and they're pouring it into cone-shaped cups until all the cone-shaped cups are filled. The question is, how many cups do we require? So watch this. We know the volume here, which was this. We know the volume of this, which is this. So you are taking the large volume and filling them in these small cups, and you're finding how many cups you require to fill all the contents of the cylinder. So let's do that. So the number of cups will be the volume of the cylinder divided by the volume of the cone. The volume of the cylinder, 9,448.96. The volume of the cone, 75.408. Take it down and work it out. All right, does anybody have an answer?
120, Miss.
120. So we require 120 cone-shaped cups to fill the volume of the cylinder. Do you all understand that?
Yes, Miss.
All right. So thank you again for joining me. We pick up tomorrow at 5:30. You all have a good night, okay?
Okay,